Hello everyone, welcome to Apex Mathematics. My name is Bino. In this video, we go through the following question which is based on geometric series. We have a geometric series which has a constant ratio r which is equals to 1 over 2 and the sum to infinity is equals to 6. And question 3.1, we calculate the first term of the series. Term number 1 is the unknown. We have the following formula of sum to infinity from the formula sheet. So sum to infinity is equals to a divided by 1 minus r. In the place of the sum to infinity, we substitute the 6, and we are to determine the first term, and we have 1 minus r, and the r we can write as 0,5. So 1 over 2 can be expressed as 0,5. And from here, 6 will be equals to, we have 1 divided by 1 minus 0,5 on our calculator, which will be equals to 2. And we still have the a. And from here, we have to solve for a by dividing both sides of the equation by 2. And the 2 divided by 2 is equals to 1. And 6 divided by 2 is equals to 3. So the value of the a is equals to 3. So this will be our first term, or term number 1. Question 3.2. So we just determined that a, term number 1, is equals to 3. Question 3.2. We calculated the 8th term of the series, and we have Tn is equals to a multiplied by r raised to the power n minus 1. So where there is n, we substitute 8. So we have term number 8, or T8, will be equals to, the a is equals to 3, and the r is equals to 0,5, or 1 over 2. And in the place of the n, we have 8 minus 1. Term number 8, using our calculator, will be equals to 3 divided by 128. Question 3.3, we are given the sum of 3 multiplied by 2 raised to the power 1 minus k, and k is from 1 up until n, and this sum adds up to 5,8125. And we calculated the value of n. So we were supposed to determine the Tn before we determine term number 8. So Tn will be equals to a. In the place of the a, we have 3, and our r is 0,5, or 1 divided by 2, and we have the n minus 1. Remember that what we have inside the summation is Tn, and that Tn inside that summation is just the same as this Tn that we just determined. It's just that they have k as the independent variable and we have n. We can prove that what we have is just the same as what we have inside the summation. So we have Tn will be equals to 3 multiplied by 1 divided by 2, and we take the 2 from the denominator to the numerator, and the exponent will change sign to -1, and this is still raised to the power n minus 1. Our Tn will be equal to 3 multiplied by 2, and that negative 1 multiplied by that n will be negative n, and that negative 1 multiplied by negative 1 will be positive 1. So we have positive 1 and negative n, and there they also have 1 minus k, and we have 1 minus n. So this is just the same as that. So we can confidently use the information that we have in order to calculate n. We already have a is equal to 3 and r is equal to 1 over 2. So our Sn, our sum to n terms, is equals to 5,8125. And this 5,8125, we can write it as 93 divided by 16. And we are to calculate the value of the n of this geometric series. And for a geometric series, we have the formula from the formula sheet as Sn is equals to a multiplied by r raised to the power n minus 1 divided by r minus 1. From here, we are at liberty to substitute, and in the place of the Sn, we are going to substitute 93 divided by 16, and in the place of the a, we substitute 3, and this will be multiplied by r, and in the place of the r, we have 1 over 2 or 0,5. We have to determine n. Our r, we substitute 0,5 in the denominator, or 1 over 2. And from here, on your calculator, you divide the 3 with the 0,5 minus 1. So 3 divided by 0,5 minus 1 is equals to a negative 6. So we have negative 6 still into 1 over 2 raised to the power n minus 1. And on the left hand side, we have 93 divided by 16. We have to solve for n. We divide both sides of the equation by negative 6, and on the left hand side, we avoid having a 3-story of fractions, so we are going to divide manually. So we are going to use the traditional division. So we have 93 divided by 16. We use this division sign, so the old one, so we divide by negative 6, and the 93 divided by 16 divided by negative 6 will be equals to negative 31 divided by 32, and the negative 6 will cancel out with that negative 6, and we are left with half raised to the power n minus 1. We move the negative 1 from the right to the left, and it will change sign to positive 1. And this will be equals to the half raised to the power n, and negative 31 divided by 32 plus 1 will be equals to 1 divided by 32. and this is equals to, so that n will affect the 1 and the 2. So we will end up with 1 raised to the power n divided by 2 raised to the power n, but 1 raised to the power n is just equals to 1. And from here, let's cross multiply. 2 raised to the power n multiplied by 1 will be 2 raised to the power n. 32 multiplied by 1 will be equals to 32. We have 2 raised to the power n on the left hand side, and for the fact that we have 2 raised to the power n, it means that on the right hand side we have to have 2 raised to the power a certain number. For now we can just call it x. So we try 2 raised to the power, so let's try 2 raised to the power 6, and 2 raised to the power 6 is equals to 64, and 2 raised to the power 5 is indeed equals to 32. So in the place of the x, we substitute 5, and since the bases are the same, for this equation to be balanced, the exponent has to be equal. So n is equals to 5. Question 3.4. If the sum of 3 multiplied by 2 raised to the power 1 minus k from k is equals to 1 up until 20 is equals to p, we write down the sum of 24 multiplied by 2 raised to the power negative k from k is equals to 1 up until 20 in terms of p. Both the sums starts at k is equals to 1 and they end at k is equals to 20. So it must be the TNs inside the sums which are related. So the first one, we are going to break the first one. Why do we break the first one? Because it has an exponent of 1 minus k, unlike the other one. So let's try to squeeze the first one and see what comes out of it. So we have 3 multiplied by 2 raised to the power 1 minus k, and this will be equals to 3. So suppose we had a raised to the power b minus c. This will be equals to a raised to the power b multiplied by a raised to the power negative c. So in the same token, that part we express it as 2 raised to the power 1 multiplied by 2 raised to the power negative k, and this will be equals to 3 multiplied by 2 raised to the power 1. 2 raised to the power 1 is equals to 2, and we have the 2 raised to the power negative k, and we have 3 multiplied by 2, which is equals to 6, which will be multiplied with 2 raised to the power negative k. So now we compare the two. So the other one is 24 multiplied by 2 raised to the power negative k. It's raining outside, so I'm just gonna try to be fast. So we have that 24, which we must compare with the 6, since we have 2 raised to the power negative k in both instances. So 24 divided by 6 will be equals to 4. So the other one seems to be 4 times bigger than the other one. So this one is 4 times bigger than that one. And remember that the other one is p. So we have the sum from k is equals to 1 up until 20 of 24 multiplied by 2 raised to the power negative k, and this is actually 4 times the p. Thank you guys for watching. If you have any questions, You can drop them in the comment section below. Remember to subscribe, like and share the channel if you find this content useful.